Hi physics friends, this is Mr. Zarzak, and in this tutorial I'm going to take you through how to set up and complete the vector walk lab. So let's get to it. As you'll come into the room, go ahead and drop off your backpacks into the cubbies. For this, really all you need is a writing utensil, and I would also suggest your iPad so that you can reference this video both while you're taking data and then later on the post-lab video for while you're analyzing your data. If you're completing the honors version of the Vector Walk Lab, please record these learning targets on your target tally sheets that were distributed in class. The text that I've added into the screen here just comes from the top of the lab, so you're welcome to pause the video and read this, or you can just read it on your own lab sheet. In a quick summary here, in the Vector Walk Lab, we're going to be working with displacement vectors, which is just how far you are from your original location. The idea is to take a vector walk around Glenbard West High School, staying on the third floor if you're upstairs and the second floor if you're downstairs, and then to determine the displacement, which is just the distance in a straight line directly from where you start to where you finish. Now the deal is we can't exactly poke holes in the walls to run measuring tapes, and so in order to determine displacement, we're going to apply vector addition. Your lab includes a handy-dandy map of Glenbard West High School for your convenience. As far as making your trip, I'm going to set some restrictions for the lab. First is that you need to stay on the same floor, and then the second is that your trip have at least 2 turns. These 2 turns need to be right angle turns, okay, so no 30 degree or 60 degree, and any other degree other than 90 degree. And that it's not that we don't have techniques to do that, but for this introductory lab, we want to keep everything as simple as possible for your understanding. So make the turns 2 right angle turns or more. If you look at the compass rose on your provided map and find room 301 for the honors room, 201 and 202 for the reg rooms. Okay, notice that down the science hallway goes to the north. In fact, if you walked out of either room 301 or 201, you'd be walking to the north. If you walked out of room 202, you'd be going to the west. And in fact, if you cross the bridge to go from the new science wing back to old Glenbard West, you'd be traveling west. Because the distances we're going to be measuring are pretty large, rather than using a meter stick or a tape measure, you're going to be using a 2-meter length of string that has been pre-cut for you. You'll need 2 students in order to do this measuring. Rather than talk about it, I'm going to show you. Have the 2 students that will be doing the measuring stretch out the string between them, each holding one end. Then to measure, it's really just a game of leapfrog. Have one student remain stationary while one walks around the other. Each time you're just adding another 2 meters of distance to the overall length that you're measuring. When you need to turn, turn. Just make sure you turn at right angles, and then repeat the process. As you're going, have another team member record that overall distance, because you're going to need those numbers when you get back to class. Once you've reached your destination, wrap up your string and come on back to class. Our 2-meter strings are special 2-meter strings, special physics 2-meter strings, laser precision cut, NASA-generated 2-meter strings. Well, maybe not, but they're still important for measuring. So when you get back to the classroom, please hang them up on that pole where you got them to begin with. The idea is to create a vector map of your walk. Vectors have 2 parts, magnitude and direction, and so you're going to need to make a drawing that is drawn to scale on the large paper that'll be waiting for you when you return to class. The measurements and the directions you went have a special name. They're called component vectors. These are the pieces that got you to your overall destination. The goal is to both draw and determine what we call the resultant vector. For the case of component displacement vectors, this is a resultant displacement vector that I've shown here in green. Notice that although the component vectors are drawn tip to tail, and so what I mean by this is that the 12-meter vector, we went this way, and then we went 10 meters this way. It's almost like these arrows are showing us the path that we took. The resultant vector is just a vector that starts where we started and points to where we ended. Okay, so here's some sample fictitious data that went from just outside room 202 on the second floor over by one of the culinary arts rooms. The idea is to take this trip out in the hallway and reproduce a map of this trip on big butcher paper. This vector graph is going to look something like this. Notice I said vector graph. Another way we can talk about the diagram is just that. We're going to graph out how the vectors all line up together to determine a displacement. In order to do this, you're going to need to set a scale. Now, the scale should be written right on your paper. The scale that I've chosen is a little bit silly because these numbers are fictitious anyway. Pick something that's convenient, but also pick something that is going to result in a diagram that takes the majority of the paper, just like we were scaling a graph. Your finished product is going to be colored. And by colored, I just mean I want all your component vectors to be drawn in one color, and I'll have some markers and colored pencils available for you to do this. When you draw your resultant, draw it in a second color so that it stands out as different than the others, and not just because it's at an angle. Although our markers are washable, they're not erasable, so I'm going to ask that the very last step that you do for this lab will be the coloring. Keep everything in pencil until you're all complete with the lab, because, well, we can erase pencil. So your diagram will look like something like this, and remember that vectors have both magnitude and direction, so the lengths of the lines matter as well as the directions of those arrowheads. The only thing that's going to be collected for this lab is the big paper. So for the lab questions, you're actually going to put those right on the big paper. When you're answering, use complete sentences. If you've got to calculate something, show the calculation, and then you know how this works. Write your equation, sub in your numbers, and then give me your answer with units. You don't need to rewrite the questions. However, when your instructor is grading this lab, your instructor will not have a copy of the lab in front of them. They're going to judge your answers based upon the way they're written. So if you're asked to find the total distance traveled, well, then frame your answer as the total distance we traveled was blank meters and show your work. Thanks for watching this tutorial, and good luck on your lab.